Hi, in this video we're going to talk more about salt hydrolysis, and now this time we're going to talk about when both the cation and the anion hydrolyzes. Now this also means that both of them are strong conjugates of acids and bases. So in that situation, we're going to compare Ka and Kb. Now if Kb is greater than Ka, then that means the solution, if Kb for the anion is greater than Ka for the cation, the solution will be basic. Now make sure you compare the Kb for the anion and the Ka for the cation. And then if it's the opposite, if the Ka of the cation is greater than the Kb of the anion, then it will be the opposite, which is acidic. Now in this case, when the Kb is greater than the Ka, the anion will hydrolyze to a greater extent than the cation, and at equilibrium there will be more OH minus ions than H plus ions, which makes it more basic. Now if Ka equals Kb, then that means the Kb anion is approximately equal to the Ka of the cation, and the solution will be neutral. Alright, now let's do some examples down here. Now first, we're comparing the Ka of the cation to the Kb of the anion. Now to find Kb, we're going to divide Kw by the Ka of the anion to find the Kb of the anion. Now we're given the Ka of the anion here, so what we need to do is grab our calculator and do 1.0 e to the negative 14th divided by 1.0 e to the negative 7th, which is 1.0 times 10 to the negative 7th. So it's 1.0 times 10 to the negative 7th power. Now the dissociation equation will be NH4 2 times SO3. Now NH4OH is going to be a weak base, which turns into a strong conjugate acid, and H2SO3 is a weak acid, which turns into a strong conjugate base. Now both of these are strong, which is why we have to take this extra step to find whether it's acid or base. Now this dissociation will be this dissolving into 2 NH4 plus SO3 2 minus. Now is this going to be acid or base? It is going to be base. Why? Because the Ka of the cation is smaller than the Kb of the anion. Alright, over here. If the Kb for the anion is greater than Ka, it is basic. The Kb for the anion is greater than the Ka of the cation. 1.0 times 10 to the negative 7th is greater than 5.6 times 10 to the negative 10th. So this is going to be basic. And the reason? Because Ka of cation is less than Kb of anion. Now next question, we're going to use the same method to find the anion, which is going to be 1.0 e to the negative 14th divided by Ka of the anion, 4.1 e to the negative 4th, which will give us 2.43 times 10 to the negative 11th. Now the dissociation equation will be, let's see, we're dealing with Al NO23. So this will just dissociate into Al3 plus 3NO2 minus. Again, if you combine AlOH3, this is going to be a weak base, which turns to a strong conjugate acid. And NO2 is going to be a weak acid, which turns into a strong conjugate base. Since both of these are strong, which is why we have to compare the Ka and the Kb's. Now, Ka of the cation and the Kb of the anion, which one is greater? Well, we're comparing 1.4 times 10 to the negative 5 to 2.4 times 10 to the negative 11th. 1.4 times 10 to the negative 5 is much bigger. So Ka of cation is greater than the Kb for the anion, which means this is going to be acidic. Finally, the last one, we're going to do 1.0 e to the negative 4th divided by 4.4 divided by 2.2 e to negative 13th, which will give us 4.5 times 10 to the negative second. Now dissociation equation will be FePO4 turns into Fe3 plus PO4 3 minus. Again, both of these will hydrolyze in water because they're strong conjugates. And now with that, to find if it's acid or base in water, we just need to compare the Ka values. So Ka is a 6.0 times 10 to the negative third, and Kb for the anion, Ka for the cation is 6.0 times 10 to the negative third, Kb for the anion is 4.5 times 10 to the negative second. That means the Kb anion is greater than the Ka cation. So Ka cation is less than Kb of the anion, which means this solution will be basic. And over here I should write basic as well. Basic solutions: acidic, base, acid, base. And this is how we find it. Again, when both of these are strong, all you have to do is compare the K of the cation to the Kb of the anion. If Kb is greater, then it's basic. If the Ka is greater, then it's acidic. Thank you for watching.